Welcome to the deep dive. Today we're getting into the world of high-stakes professional AV distribution.
Right.
We're talking about the backbone for places like casinos, huge sports bars, command centers.
Yeah, places where you just can't have failure. And speed is everything.
Exactly. And our deep dive today is looking at the WolfPack line of modular matrix switchers from a company called HDTV Supply.
They've been in the AV game for, 25 years now?
A long time.
So our mission here is to really unpack how their modular system solves some of the biggest headaches in the industry. Things like signal compatibility, reliability, and just pure speed.
So let's jump right into that. When you've got a massive system, say a 36 by 36 matrix in a casino, and one part fails,
Yeah.
what happens? Why is replacing a single card such a big deal?
Well, that's the core of it, really. It's designed for resilience. They have these chassis from a small 9 by 9 up to the huge 36 by 36.
Okay.
And they all use these one-slot card cages in let's say, a more traditional setup. If one component goes down, you might have to power down the whole rack.
A whole thing goes offline.
The whole thing. Here, if one screen goes black, you know the failure is on that one specific card. You pull it out, you pop a new one in.
So you're turning days of downtime into, what, minutes?
That's the idea. It guarantees uptime and keeps the entire system from crashing over one bad part.
That makes a lot of sense. And what about future-proofing? Technology moves so fast, I saw a mention of a MAV card.
Right, the modular audio-video card. This is where they're thinking ahead. Their R&D team developed it with a DVI port.
DPI, that seems a little old school.
It sounds it, but it's actually genius. It's so versatile. With a simple adapter, that one port can handle modern HDMI, old VGA, even legacy component video signals.
So you can plug almost anything into it.
It basically builds adaptability right into the hardware.
Okay, but flexibility is one thing. We've all seen that, that blinking screen, the dreaded handshake issue where devices just refuse to talk to each other.
The silent killer of any presentation.
Exactly.
Ow.
How do they deal with that signal mess?
They have some pretty smart tools for that. At the hardware level, the cards have these little 8-pin DIP switches.
For manual control.
Yeah, an installer can literally flip a switch to adjust scaling the resolution to force the source and the display to get along. But even better is the EDID learning.
Okay, how painful is that? Because EDID errors are a nightmare.
According to the sources, it's incredibly simple. You connect a display, you press the EDI key on the card twice, and that's it.
That's it.
It just copies the display's ideal settings and stores them. No more signal errors. Plus, they handle audio really well with options for de-embedding audio to, standard 3.5mm jacks.
Let's talk speed.
Yeah.
The term they use is seamless switching. They're claiming a switch in 100 milliseconds. That's a tenth of a second.
It's basically instantaneous to the human eye.
So why do other switchers take like 5 or 6 seconds sometimes? What are they doing differently?
That delay you're talking about comes from the digital handshake. A normal switcher does the EDI check, then the HDCP copy protection check, one after the other. It's a sequence.
Oh. The WolfPack engine does all of that stuff simultaneously. It's processing those protocols at both ends, the source and the display, at the same time.
So it cuts out the sequential waiting period.
It completely eliminates the blackout delay. You just get a clean, instant cut.
That's a huge deal in a live environment, and obviously these systems have to integrate with professional control rooms. Do they play nice with others?
They have to. And
Yeah.
yeah, they're compatible with all the big names. Crestron, Control4, AMX, Savant.
The usual suspects.
Right. But here's the real kicker. This is the financial nugget for you. They give advanced users a simple RS-232 scripting guide. Little command like echo and 8 and 16 lets an installer write a custom driver from scratch.
And what does that mean in terms of cost? Because proprietary control software is notoriously expensive.
We're talking thousands, sometimes tens of thousands of dollars.
Wow.
So an end user can buy this TAA-compliant hardware directly, hire a local integrator to write some simple software, and completely bypass those massive closed system licensing fees. That fundamentally changes the ROI calculation, doesn't it? And they back it with a solid warranty, too.
A 2-year advance replacement warranty. They ship a new unit within 24 hours in the US. It's a powerful combo.
So to sum it all up, the value is really twofold.
I think so. First, you get the modularity that guarantees uptime. And second, you have this open scripting system that saves a ton of money over the big proprietary players.
We've seen how hardware flexibility like that MAV card handling all these different video signals is really the key to making these systems last.
It is.
And that brings up a really interesting thought for you to take away. If being compatible with legacy devices is this critical for high-stakes AV, what legacy devices might you need to future-proof in your own tech world? Something to think about.